So good morning, students. Today our lecture is about polar coordinates, and before we discuss polar coordinates, let's review what do we mean by rectangular coordinates. So before we discuss the polar coordinates, let's review the Cartesian system. The Cartesian system is the rectangular system or orthogonal system because the axes, the x and y axes, are perpendicular at the center. If I want to draw a point on the Cartesian system, so this point here has an x coordinate of 2 and a y coordinate of 3. This point at the origin, so it's going to have the x and y coordinates as 0, 0. This point, if I want to locate -4 and 2, so it's gonna have an x coordinate of -4 and y coordinate of -2. And this is like a quick revision about the rectangular coordinates. Now with polar coordinate system, the system is different. Notice we have circles, and these circles have certain radii, and we have angles. Now the axis on the origin. Now the axis on the origin is called the polar axis. Any point in the polar coordinate system is represented by a radius and a certain angle. The circles that we're seeing has radii of 1, 2, 3, etc. And any point depends on the radius and the angle. So let's take an example. Point P has a radius of 6 and angle of 75. So this is the angle. Let's see how it is determined. So there's an angle of 75. This is a circle of radius 6. So point P is determined by the radius and the angle. So now let's try to plot points. It's our turn to plot points. Is 2 and 150 degree. The first thing you should come to your mind is locate the angle. So what is 150 degree? This. And then now you need to take a circle of radius 2. So that's a circle of radius 2. Where these intersect, the angle and the circle is going to be my point. Another point, -3, and has an angle pi over 2. So the first thing, locate the angle. That's where pi over 2. Now, since the radius is negative, the point is going to be on the other end of the angle. Also on a circle of radius 3. This point has a negative angle and a negative radius. So the negative angle is -pi over 4. Again, how do we locate -pi over 4? First, let's discuss what is pi over 4. Pi over 4 is here, is 45 degree. So -pi over 4, just flip this angle along the x-axis, and that's where going to be -pi over 4. Now we need the radius, a circle of radius 6, but since it's negative, so my point is going to be on the other end of my angle. Let's take another point. We have 5 and 0 degree. It means this angle is on the polar axis. So therefore, definitely with a circle of radius 5. So that's my point, 5 and 0 degree. The last point is a -pi over 6 and the radius of 4. So -pi over 6, first of all, pi over 6 is here. Just flip it along the x-axis. is going to be on 330 degree. 4, okay, the radius is positive, so my point is going to be with my angle and not on the other end. So keep in mind, when we have a negative radius, the point is going to be on the other side of the angle. If I have a point in polar coordinates, I can write this point in 3 ways. Now, if I want r to be positive and theta to be between 2 pi and 4 pi, I can add 2 pi to my angle, and definitely adding 2 pi to pi over 3, that's going to give me 7 pi over 3. And that's how we do it. Notice that by adding 2 pi, the position didn't change, but definitely the naming has changed. So the new point is now 2 and 7 pi over 3. Now, if we want r to be negative and theta between 0 and 2 pi, we can add pi to pi over 3. Therefore, the new point is going to still have the same position, but the naming is different, definitely, because we're adding pi to pi over 3. So the new angle is 4 pi over 3. And since this point is on the other end, so the radii is going to be negative. So if we want r to be negative and theta between 0 and 2 pi, so we just add pi to our angle. Definitely the new angle is 4 pi over 3. But since this point is on the other end, so the naming is going to be negative 2, 4 pi over 3. Now, if we want r to be positive and theta between negative 2 and 0, we can subtract 2 pi. So we can subtract 2 pi from pi over 3. So we're subtracting 2 pi from pi over 3. And we're going to still get the same position of my point, but the naming is different. So this point is going to have a new coordinate with 2 and negative 5 pi over 3. So notice, if a point is important coordinate, we can name this point in 3 ways without sacrificing the position of that point. So definitely the angle is going to change. The radii might be different, might stay positive, might stay negative. But so either by adding 2 pi or by subtracting 2 pi or by adding pi. So in this slide, we're going to talk about the relationship between polar and rectangular coordinates. So if we take an angle, we know that cosine theta is x over r, which is the hypotenuse, and sine theta is y over r. Tangent theta is y over x. So this is the relation between polar and rectangular coordinates. So if we have an example here, we have a point in polar coordinates and we need to change it into rectangular coordinates. So first we apply that x equal to r cosine theta and y equal r sine theta. So taking these, plug in the information. We plug 2 for r and pi over 3 for theta, and we got x as 1. The same with y, but we're taking sine theta instead. It was square root of 3. Therefore, the rectangle coordinates of 2 and pi over 3 is 1 and square root of 3. So now here we have a point, and we need to convert that point from rectangular coordinates to polar coordinates. So we see that point is expressed in rectangular coordinates, and we need to write it in polar coordinates. So we know that any point in polar coordinates has a radius and an angle. So first we're going to start finding the radius, and we're taking the equation of the radius, which is square root of x squared plus y squared. And we have the x as 1 and the y as square root of 3, and squaring these two, taking the sum, take the square root of the sum, which is square root of 4, that's 2. Now, the relation of the angle between y and x, the only relation that relate x and y is the tangent. So we took tangent theta equal y over x, square root of 3 over 1, square root of 3, therefore theta equal the inverse tangent or arctangent square root of 3, which is pi over 3. I can find this on the calculator from the trig circle. So the polar coordinates of point P is 2 and pi over 3. So now here we have a similar example, but I just want you to see the relation. So we have another point, let's name it A. It has rectangular coordinates -1 and square root of 3. So here when we have the cosine as negative, so that's so this angle is in quadrant 2. So first of all, we're going to start by finding the radius. The radius is similar to the other one. It's not going to be effective because we are entering a negative number, and when we square it, it's not going to be effective. The answer is 2. Now the tangent is going to be negative because we have one of the coordinates is negative. So the tangent is negative square root of 3. And this angle, who has a tangent of negative square root of 3, is 2 pi over 3. But notice we can find it as pi minus pi over 3. Therefore, so we notice the relation between the previous example and this example. We know that tangent pi over 3 is square root of 3. So we can subtract pi over 3 from pi, and we get 2 pi over 3. So we know, since we have the x coordinate as negative, it means theta is in quadrant 2. So we can approach also this exercise. Since we know that tangent pi over 3 is square root of 3, so we can subtract it, or we can find it on the calculator by taking the inverse of a tangent. Therefore, the polar coordinates of A is 2 and 2 pi over 3.